So this is an example that I accidentally skipped over in the lecture video. I was working the problem above it, and my work covered this problem up. So I want to come back and hit this problem. And the directions say, find the equation of the tangent line if given the function and the point, okay? This is a question that you're going to be given all semester long to find the equation of the tangent line. You're going to have that throughout the rest of this course. The only difference is going to be that the way we find the derivative is going to be different. Right now we're using the limit definition to find the derivative. But later on, you're going to learn all different kinds of differentiation rules that you will apply to the derivative, and it'll make finding the derivative more efficient. But the point is, when you are finding the equation of a tangent line, the derivative, and let me comment in red, the derivative is used to find slope so m of tangent line So slope is used, the derivative is used to find the slope of the tangent line. And once you have the derivative, all you do is plug in x into that derivative. And that x comes from this x value right here. Anyway, this question is not simply asking for the slope, it's asking for the equation of the tangent line. So here's another comment. So once we know the slope of the tangent line from this step right here, once we know the slope at a particular point, because we plugged that x value in, we can find the equation of that tangent line by using the point slope formula. And the point slope formula says y minus y sub 1 equals the slope times x minus x sub 1. And all you'll have to do is plug in your slope and your point into that formula. And again, you're going to be doing this all semester long. The only thing that will change throughout all these steps stay the same throughout the semester. The only thing that will change is this right here. We're gonna learn different ways to take a derivative. So we're going to use the limit definition to find the derivative. And let me just say f prime, the derivative, equals. And in order to use that limit definition, I need to know what f of x plus h is. And so I just took f of x, which was 3 over x minus 2, and plugged x plus h in where x was at. So just 3 over x plus h minus 2. So this becomes the derivative, we will say, will equal the limit as h approaches 0 of 3 over x plus h minus 2 minus 3 over x minus 2 all over h. And if I evaluated this right now, it's going to be an indeterminate form. So I'm just going to keep on going. I need to find a common denominator in the numerator. That common denominator within the numerator is going to be x plus h minus 2 times x minus 2, and I got that by just multiplying the two denominators together. And what I'll need to do is where we had just a 3 in the numerator of the numerator before, it will need to be multiplied by x minus 2. Because now that side is technically being multiplied by x minus 2 over x minus 2, which is 1. Okay, and the 3 on the right side needs to be multiplied by x plus h minus 2, because now that right side is being multiplied by x plus h minus 2 over x plus h minus 2, which is 1. So in this step, you can see where I've distributed the 3 and the negative 3, and got 3x minus 6 minus 3x minus 3h plus 6. Be careful with the distribution of the negative. Anyway, from my next step down here, the numerator, I combined like terms. So the 3x and the 3x canceled, and the 6 and the 6 canceled, to leave me with negative 3h. But all of a sudden, instead of having a fraction within the numerator, I can take the denominator and put it, the denominator of the numerator, and put it in the big denominator, I guess you could think. Okay, so along with h in the denominator, I now have the denominator that was in the numerator. And it's perfectly okay to do that, okay? So if we evaluated this, which I can now evaluate because the h's cancel, I'll end up with that negative 3 in the numerator, and as h goes to 0, that goes away, right? So x minus 2 and x minus 2 is x minus 2 squared. And just remember that this is the derivative. Well, that's not the answer to the question, right? The answer to the question asks for the equation of a line. Well, I need the slope and the point for the equation of the line. Well, I know that the point is 4, 6. And the slope will be f prime. So your derivative, but with plugging the 4 in for x. Negative 3 over 4. So I have everything that I need for my point slope formula. So this is the last part. Y minus y sub 1 equals the slope times x minus x sub 1. I do suggest you write the equation, the formula every time that you do this, so that you can memorize it, because again, you will be doing this throughout this entire class. So y minus 6 equals negative 3 over 4 times x minus 4. And we're going to distribute, we're going to get it in y equals form, but I'm going to distribute that slope to the x and to the 4. It's going to become positive, and negative 3/4 times negative 4 is positive 3. I'm now just going to add 6 to both sides to get 9. And this is the final answer. This is the equation of the tangent line at the point 4, 6.